the answers and those who didn't get the answers. So no problem. Yes, good Rishabh and Aishwarya. I think some of you shared with me also in the WhatsApp. I verified and I told you to do one thing regarding to that third problem, right? So regarding to the third problem, I asked you to apply mesh analysis, right? Yeah. I think so. That means I received from the most of the students, and most of the students get the correct answers also. So that's good. Okay, Avantika, you can contact me later. Okay, no? Right. So please respond every student whether you solve their problem or not. Yeah. So whether you solve their problem or not, and if you try, definitely you will get the answers. And if you didn't get the answers, that's also no problem. Okay, now. So wherever you stop now, okay, you can contact me in the free time so that I will explain. Anyway, I will provide the solutions for them also. Right? Yeah. Directly, I will share my screen. Okay. Yeah, good, Snehalata. Right. Yes, my screen is visible, right? Yes or no? Yeah, good, Javed. So anyone, so total how many theorems we are going to discuss in the first unit? And what are those? Two theorems, right? Yeah, good. What are those two? What are those two theorems? So one is, yeah, good, superposition theorem, and the second one is what? So Thevenin's theorem, right? Okay, now, so today we will see the superposition theorem, and I already told you the importance of the theorem also. Yes or no? In yesterday's class, I already told you the importance of a theorem by considering one problem, and I explained you where we are using these theorems. Theorems are used to find the response in a particular element. Okay, now, so wherever you want to find the response, then we will apply theorems. And in that network theorems, we are having and we are going to discuss two theorems. One is superposition theorem, and the second one is Thevenin's theorem. Forget about those things. Before that, before understanding the theorems, first we should know understood one important topic, may consider topic, right? That is, I will tell you. So before discussing about theorems, yes. Yes, my whiteboard is visible, right?
Yeah, sir.
Yeah.
Yes, sir.
Good. So before, so actually, to understand the theorems, okay, now, to understand the theorems, first we should know two terminologies. So the first one is observe. The first one is short circuit. Okay, the first one is short circuit. So right. So now very one. So what do you know about a short circuit? Yes, can you respond? What do you know about a short circuit? And what is happening when there occurs a short circuit? And what do you know about a short circuit? And what is happening when there occurs a short circuit? Yes, can anyone respond?
Just positive due to excess of current.
Yeah, good. Excess of current. And so in most of the time, all of you observe, if you observe, that means if you read a newspaper every day, okay, now, so on an average, you can find out at least one, okay, now, so one news about this short circuit, and every day on an average. So and so place, Okay, now so and so place, there occurs a short circuit, and that leads to fire accident. And because of that, there is a huge damage like that. Yes or no? And every day, so on average, we may observe that type of news in the newspaper. That means indirectly, what we can comes to know that when there is a short circuit, okay, now that leads to fire accident, right? Yes, and that's what the meaning internally. So when there occurs a short circuit, that leads to fire accident. Now my question is, so why we are getting a fire accident when there occurs a short circuit? Can anyone respond? Yes. Can anyone respond? Exactly what is happening when there occurs a short circuit? Have you observed any short circuit situations?
Overheat produces, sir.
Why we are getting overheat? Yes. Why we are getting overheat when there occurs a short circuit?
More amount of electrons.
Due to the collision.
Yes.
Due to the collision.
Due to the collisions, good. So why we are getting the collisions? So even normal, in normal situation also we are getting collisions, right? Yes or no? But why we are getting fire?
Current is high, the number of collisions will be
More
more.
current, more collisions, sir.
Yeah, good man. I think you all are, that means you are all good at analyzing the skills. That's excellent. And now exactly we will see. I will tell you. I will try to tell you exactly what is happening when there occurs a short circuit. Before that. So now is it possible to make a short circuit? For us, is it possible to make a short circuit? Is it possible or not? I want to make a short circuit. How to make a short circuit? Can you tell me? Yes? Anyone? How to make a short circuit? I think in the movies also they are showing, right? How we are making a short circuit. Anyone? So how to make a yeah, good. Connecting
Two different wires.
two different wires. Okay, somewhat.
Which are,
Any other answers? How to make a short circuit? Very simple, right? Yeah, good man. All of you agree. Don't think that I'm saying that how to make a short circuit at your homes. Okay, now. Right. So if you want to make a short circuit in your home, you can find out some plugs will be there now, connecting plugs. Okay, now. So yeah. So in the plugs, you can find out the plug will be like this only. One big hole will be there, and then yeah, good man. We will say. I will tell you later. I will tell you why we are having this much. Okay, now size, and the remaining holes are yeah, good man. Earthing wire. Do you know the reason why?
yes, sir.
Why? Why the earthing terminal should be large compared to the remaining phase? So these are called phase. This is phase terminal or neutral terminals. So why the earthing? So this is for exclusively we are using for the earthing terminal.
There is no problem. There is no lot of problem with earthing, sir.
That's for that. Yeah, good. For that purpose, yeah. For that purpose only we are using that earthing terminal. But the question is why this size compared to normal? The earthing terminal having big size, right, compared to normal. Have you seen or not, all of you? Have you observed in your home the plug holder? So I can say this is the holder. The holder, it looks like this, right? So this may be phase and this may be neutral, and I can consider, I am telling, maybe some students don't know, this terminal will be, I consider it as earthing holder. This is earthing holder, this is a phase, and this is the neutral. And if you observe the size of the holes, okay, the earthing terminal holder is big size compared to remaining. Why? What is the reason? What is the reason?
When short circuit happens, it
Yeah,
reduces that
when short circuit happening, it reduces what?
effect.
Effect. What is that effect? Okay, so you are having some idea, but you are that means you are finding it difficult to express that. That's not a problem. Okay, now we will see what is the purpose of this one, and what is happening when there occurs a short circuit. and the consequences of the short circuit. All these things we will discuss. So one by one. Right. First of all, if you want me to make a short circuit, simply I can make a short circuit like this. Simply, if you connect a wire, okay, now, if you connect a wire between this phase and neutral directly, okay, if you connect a wire between this phase and neutral directly, that leads to what? That leads to, I'm telling, yeah, I'm telling, you don't know maybe, okay, now, I'm telling that leads to short circuit. Simply I'm telling that leads to short circuit. We will see why, so that leads to short circuit. We will see. I'm telling that if you connect a wire between these 2 points, that is phase and neutral point, that leads to short circuit. Okay, to understand that, the same thing, I consider a big network. Okay, the network may be your home itself. Consider your complete your home. Okay, now your complete home I consider as a network, and your holder will be there now in the switch box. The holder, these are the 2 terminals, complete network, and for this network I can see these 2 outcoming terminals, and I am giving the names for the 2 outcoming terminals A and B. That is A means phase, consider phase terminal, and B means neutral terminal. The same here. These 2 terminals I am indicating here. The remaining network I am indicating like this. Okay, now. So now what I am telling means, if we connect a wire directly, conducting wire, not normal wire. If you connect a conductor between the 2 points A and B, yes or no? That leads to what? Short circuit I'm telling. Yes or no? That leads to short circuit I'm telling. So which type of material we are connecting between the 2 points? Is it a conductor or any other metal we are connecting here there? We are connecting a conductor, right? Yes sir, there is no doubt. That should be a conductor only. Okay, now. But ideally speaking, keep in mind, ideally speaking, the resistance offered by any conductor, ideally speaking, the resistance offered by any conductor, that is equals to 0 only. Keep in mind, ideally speaking, the resistance offered by any conductor, that is equals to 0 only. Now what I am telling means, in a network between the 2 points, I am connecting one connecting wire, and the resistance offered by that connecting wire, I assume that, ideally speaking, so that resistance value equals to 0. Okay, now can you find out what is the voltage across these 2 points A and B? We will try to find out, we will observe how much voltage it will appear across the 2 points A and B. Okay, I consider that voltage as VAB, right? And the current passing through these 2 points, yeah, so it is a closed circuit or open circuit? We are closing or opening these 2 points A and B. Closed circuit. Closed circuit means definitely there is a flow of current or not?
Yes, sir.
Current is there. Current is not equals 0. Okay, now so consider that current value as, okay, I consider that current value as IAB. Okay, now I consider that current value as IAB, and the voltage between the 2 points A and B I consider as VAB. But similarly, I consider the resistance offered by that conductor as 0. Okay, so instead of a normal conductor, now what I am doing means, I am considering a thick conductor. Okay, now I am considering a thick conductor. So if the conductor size increases, thickness increases, then what about the resistance value? What is the relation between thickness and resistance? What is the relation between thickness and resistance? Thickness means what? Cross-sectional area, right? Yes or no? So cross-sectional area increases. If we are increasing thickness means, so cross-sectional area increases. So what about resistance value? Decreases or increases? Decreases. That is the reason why yeah, good man. That is the reason why I consider a conductor with resistance almost equals to 0. Now if the resistance value goes 0, now whenever, what is the current through this path AB? Before that, we will find out what is the value of VAB. Okay, now the voltage drop. Yeah, good. So the voltage drop across the 2 points VAB. VAB equals to what? According to Ohm's law, VAB equals to what? The current IAB, right?
IR.
Yeah, good. IR. So current IAB into the resistance R. But here the resistance offered by the conductor is how much? 0, right?
0.
Yeah. So if the resistance value is 0, then what about the voltage across the 2 points AB? Is there any voltage?
0.
Good. So there is no voltage up there. That means when there occurs a short circuit, okay, now, when there occurs a short circuit, the voltage value is 0. Everyone accepted? The voltage value is 0 because the resistance of the conductor is 0. Now can you find out the current value? Ma? What is the current value? IAB.
Infinity.
Good. So very simple. So I can write IAB equals to, ideally speaking, I am speaking ideally. So simply IAB equals to the voltage. Yes or no? And by the resistance R. But here the resistance value is how much? 0, right? Yes or no?
Yes.
The resistance value, if the resistance value is 0, then what about the current value? Ideally speaking, the current value is infinity. That means when there occurs a short circuit. So why we are calling this as a short circuit means, so after connecting the conducting wire between the 2 points, the current passing through that path is how much? How much current is passing? Ideally speaking. So infinity amount of current is passing through that path. And what is the voltage across the 2 points? It is 0, right? Good. That means, so because of the infinite amount of the current, okay now, so because of the infinite amount of the current, if the current passing through the conductors, okay now, if the current passing through the conductor increases, if the current passing through the conductor increases, whatever the heat dissipation in the conductor, what are heat dissipation? Heat dissipation means indirectly what it means? It is due to number of collisions, right? Yes or no? The number of collisions, when the number of collisions increases, current increases. Good, Ankita. So if the current increases, that leads to large amount of heat dissipation. That means if you consider your home itself. So in our home we are having wires now, conducting wires. So that conducting wires can withstand a current of 5 amperes only. Okay, can withstand a current of how much? Just 5 amperes only. That means if the current exceeds more than 5 amperes, if the current exceeds more than 5 amperes, that will be happening when there occurs a short circuit. If the current exceeds more than 5 amperes, then that wire leads to burning. Okay, now if the wire is burning means that leads to fire accident. That is what is happening in case of a short circuit. All of you understood. That is what is happening in case of a short circuit. So when there occurs a short circuit, that leads to a large amount of current. But the voltage across the short circuit path is 0. Because of the large amount of current that leads to, so the dissipation of the heat in the conductor, that leads to fire or burning of the conductor. That is the reason why, so we are getting fire when there occurs a short circuit. But so to avoid this problem, actual observe, to avoid this fire accidents or short circuit, in our home we are using some safety equipments like MCB box. Yes sir, now we are using MCB box, right, in our home? We are using them? No?
Yes, sir.
So you can find out in your home. Definitely we are having MCB box. If you are not having MCB box means keep in mind, better to keep MCB boxes in our homes. Okay, so why you are using MCB box means MCB box. If the current passing through that MCB box, if it exceeds its limits now, simply it will open. That circuit will be opened. When there occurs a short circuit anyway, simply so that MCB box open the switch. Then there is no current passing through your wire. That is how we are overcoming this problem, short circuit, in our homes or in the real time. But even though we are getting some fire accidents, it is because of less maintenance. Okay, no? So we need to maintain, or we need to observe that MCB boxes regularly, whether they are operating properly or not. Okay, no? So some maintenance we require. Okay, if you're not looking into that MCB box means, so suddenly when there occurs a short circuit, that leads to fire accident. Everyone understood, right? So why we are getting fire accidents? So when there occurs a short circuit, right? Yeah, good. All of you keep it in a short circuit and note down the definition. Note down the definition. So how we are defining the definition for short circuit is when any 2 points, note down parallelly. So when any 2 points, right? When any 2 points in a network, okay, now so when any 2 points in a network are joined directly, yes or no, or joined directly with each other, with a what? With a thick, okay, na?
Conducting wire.
Good, metallic conducting wire, preferable. So with a thick metallic conducting wire, right? The thick metallic conducting wire. Then the 2 points. Then the 2 points are said to be short circuited, right? Then the 2 points are said to be short circuited. And resistance offered by the short circuit path is how much, ma? Ideal speaking, 0. Good. Resistance offered by the short circuit path is 0. This is how we can define short circuit. So simply you can remember, when there occurs a short circuit, that leads to large amount of current. Because of the large amount of the current, that leads to fire accident. Understood what is happening exactly when there occurs a short circuit? Yes. Let's complete everyone. So copy that network. This explanation, copy it everyone, and write the expression for the voltage and currents across the 2 points A and B. Let's copy it fast, a little bit. All of you understood what is happening when there occurs a short circuit? Yes or no? Yes. Good. Next, keep reading as once if you complete the short circuit. So copy it, so everything. Okay, at the end I will tell you, ma. At the end I will tell you the importance of this earth holder or earth conductor. Why the size of the earth holder is bigger than the size of the normal terminals. I will tell you, no problem.
Sir,
Yes.
sir, first line is not visible, sir.
It's not visible. Huh? Anyway, I dictated, right? You are not copying, no? I dictated or not, ma? Now it is visible, right?
Sir, I want to take a picture, sir.
Yeah, no problem. Now it is visible, right?
Yes, sir.
Yeah.
Yes, sir.
Okay. Right. Yes, copy it, ma. Make it fast, everyone. So once copied, now keep adding as the open circuit. We will see what is happening or what is the meaning of open circuit also. So once if you understood short circuit now, the open circuit is very simple, right? So make it fast a little bit. Completed, everyone. Please respond once completed. Copied, right? Yes or no?
Yes, sir.
Yeah, good, ma. So once copied, all of you keep bringing as open circuit. All of you copy. So keep it as open circuit. Now we will see what is happening when there occurs a open circuit. Again, I will consider a network like this, same as like earlier. Okay, now I will consider a network like this with 2 terminals. Right. Again, so this is also having 2 terminals. Now, anyone, if there occurs a open circuit, what is the value of? Is there any voltage? There occurs a open circuit.
No, sir.
And what about current values in open circuit?
Current also 0.
Current also 0 and voltage also 0, na?
Yes, Yes, sir.
Yeah, good. So anyway, we'll observe here now. I consider a network like this with some resistors also, with some elements. And I consider that resistance values also. Consider this resistance value as R1. Okay, na? And consider this resistance value as R2, right? And this is the given our network. The network may be anything. That's the reason why I'm representing with dotted lines. So this is my network, and I consider the current passing through this. Okay, na? Current passing through this R1 as I1. Okay, na? I1. Now what I'm doing means, again, so consider this terminal as A. Okay, na? And consider this terminal as B. So now what I'm doing means I'm opening the two terminals. That's the meaning of open circuit, right? I'm opening these two terminals. If you open these two terminals, now anyone, what is the value of current I1? I'm disconnecting these two terminals. If you disconnect these two terminals now, then what is the value of this current I1? Is there any current?
No, sir. Zero.
No, right? So current becomes 0, right? There is no current. Current becomes 0. There is no doubt, right? So clear. So that means, so when there occurs a open circuit, okay, now when there occurs a open circuit, the current passing through the open circuit path is how much? 0, right? Simply right now. That is IAB. That is equal to 0. So simply the current passing through that open circuit path is 0. Right. Now we need to observe whether there is a voltage or not between these 2 points. Okay, now. So we need to observe. And similarly, keep in mind, if you want to find out, okay, now, if you want to find out voltage across any 2 points, you need to apply which law? Which law I need to apply? If I want to find out voltage, we need to apply KVL. Keep in mind. Okay, so Kirchhoff's voltage law. If you want to find out voltage between any points, any 2 points, we need to apply KVL. In this case also, I want to find out what is the voltage between the 2 points AB, right? Yes or no? And consider that voltage as VAB. Okay, now consider that voltage as VAB. If you want to find out that voltage VAB, we need to apply what? KVL. In this loop, we need to apply KVL. Observe here. In this loop, we need to apply KVL. Consider clockwise direction. How to apply KVL? First, we need to indicate what? Polarities, right? Yes or no? And I consider the current passing through this resistor is I2. It's not an open circuit, right? Yes or no? It's not an open circuit, right? Yeah. Now, anyone, what is the polarity here? What is it here? Is it positive or negative? All of you observe the current direction there. The I2 current, it is passing through the resistor in a downward direction or upward direction?
Yes, sir.
Downward means what is the polarity here? Positive.
Negative.
Yeah, not negative. Subject current is passing through resistor in downward, right? So what is the polarity here? Negative.
Yes, sir.
Good. Now anyone. So is there any voltage drop across this resistor R1? Is there any voltage drop across resistor R1? No, right? Good. So why means the current value is 0 now? There is no voltage drop. No need to consider. And similarly assume the polarity for this VAB is plus minus. Okay, now can you write the KVL equation start from R2 in clockwise direction? What is the KVL equation? I am moving from where to where? Minus 2 plus means? Minus 2 plus means plus or minus? Plus, good. So that voltage drop is how much? I2 into R2, right? Yes, sir. I2 R2. Now coming R1, there is no voltage drop. Now coming here, again plus 2 minus. Plus 2 minus means minus or plus? Minus. Good, minus. Minus, that voltage I consider as VAB. That is equals to what? Is there any other terminals? Other elements? No, right? That is equals to 0. Now what is the value of VAB? The voltage across AB. How much? VAB equals to how much?
I2 into R2.
Good, I2 into R2. That means when there occurs a open circuit, the current value is 0, but what about voltage? The voltage is 0 or not? It is not equal to 0. Very, very important. So when there occurs an open circuit, so the voltage across the 2 points will be there. There is no doubt. Voltage will be there, but the current passing through the 2 points is 0. Okay, now. So understood the difference between short circuit and open circuit. So in case of short circuit, the voltage is 0, but the current value is ideally speaking infinity value. But in case of open circuit, current is 0, but ideally speaking, current is 0, and voltage value is how much? Some value will be there. That is not a question. All of you understood the difference between open circuit and the difference between short circuit. Okay, and the properties of short circuit and open circuit. Right? All of you note on the definition for the open circuit. All of you note in the definition for the open circuit. When there is no connection, note on my everyone. When there is no connection, when there is no connection between the network, so when there is no connection between the 2 points of a network, no connection between the 2 points of a network, then the 2 points are said to be, then the 2 points are said to be, then the 2 points are said to be open circuited. Yes or no? Said to be open circuit. Yeah, that's it. There is no connection. We are not connecting anything. That's it. And the 2 points are said to be open circuit. Understood, everyone? The difference between short circuit and open circuit. This is how we can differentiate. All of you copy this network also. Do it. And apply KVL also. So I will write here also. KVL also I will write. That is I2 into R2 minus VAB, right? Equals to 0. Then VAB equals to VAB equals to I2 into R2. That's so in this case only, I'm telling. Finally, you need to keep in mind that when there is a short circuit, the voltage value is 0, current value is infinity, and when there occurs a open circuit, current value is 0, but voltage is not equal to 0. Okay, na? These 2 points you need to keep in mind. Understood, everyone? Copied? Copied? Copied or not?
Yes, sir.
Good, ma. So once,
Yes, sir.
yeah, good. So once copied now, all of keep adding as, now we will move to the first theorem, that is superposition theorem. Keep adding as superposition theorem, right? I think yesterday I already asked you, did you hear this word? I think most of the students said no. Did you hear that word, ma? Superposition principle, I think you heard that.
Yes, sir.
Superposition principle, no? Yes or no?
No, sir.
Yeah.
No, sir.
Yeah, good, ma. No problem. That's no problem.
No,
Right.
sir.
So now we will try to understand exactly. Yeah. So we'll try to understand the statement for the superposition theorem and how to apply the superposition theorem to solve any network. So before that, I will consider a network like this. Just listen, everyone. I will consider a network. So like this. With 3 resistors. So with 3 resistors and 2 voltage sources. So here I will connect one voltage source, and here also I connect one source. Here I will place one resistor. This is also one resistor, and this is also one resistor. Okay, right? And I will mention the values also. So the value of this resistance is 2 ohm. So parallel you can copy it more. And the value of this resistance also 2 ohm. And the value of this resistance also 2 ohm. Okay, na? And but the voltage sources, this voltage value is 10 volts, and this voltage value I consider as 20 volts. Okay, na? This voltage value, so I will consider as 20. I will mention the values. This is 10 volts, right? This is 20. What are resistance values? 2. 2. And this is also 2, right? Now what I want to, what I'm expecting from your side is, I want to, so you want to, that means you want to find out what is the current passing through, okay, now, what is the current passing this 2 ohm resistance? How to find out? How to find out what is the current passing through this 2 ohm resistance? How to find out, ma? This current I want. Yes. How to find out this current?
KVL.
KVL. If you want to apply KVL, means you should know current. Good, ma. Mesh. Yeah, good. Good. Mesh analysis we need to apply, right? Okay, now. So all of you copied the problem, right? All of you apply parallel apply. Mesh analysis everyone apply, ma. Everyone apply for this one. And I consider this mesh current as I1, and I consider this mesh current as I2. Parallel do it, ma, everyone. Okay, na? This mesh current as I1 and that mesh current as I2. And I consider both the current in preferably clockwise direction. Right? That is your choice, ma'am. You may consider clockwise or anti-clockwise. That is your choice. But preferably I will consider this I1 current in clockwise and I2 also in clockwise. Right? Now can you tell me the KVL equation for the first loop? I don't want even. I don't want to indicate the polarities. Can you write directly without indication? What is the polarity here? Plus, right? Minus. Good. Minus.
Minus.
Yeah. And similarly, can you tell me for here? Plus.
Plus.
Good. So minus. And coming here, it is positive and negative. Very simple problem I consider. And this is what? Positive and negative. Good, ma. Right. Now can you write the KVL equation for the first loop? Start from 2 in clockwise direction. We are moving from where to where, ma? Positive to negative, right? Yes or no? Positive, yeah. Good. Minus 2 into
2I1.
Good. 2I1. So minus 2I1. Then what about this? Again plus 2 minus now. Plus 2 minus means again minus. Yeah. Minus 2, again 2, right? But what is the current here?
I1 minus I.
Good. I1 minus. Good. I1 minus I2. That's it. And then what are this 10? So what about 10? So for 10, observe here. But when it comes to 10, now we are moving from where to where? Minus 2 plus, right? Minus 2 plus. Minus 2 plus means?
Yes, sir.
Plus or minus? Plus, right?
Plus.
10. Good. Plus 10 equals to 0. Yeah, good, ma. Now can you simplify this equation? So you will get minus 2I1, right? Yes or no? Minus 2I1, no? No. Minus, so good, minus 4I1 you will get here. Minus 4I1 you will get. Plus, right? Plus 2I2, right? Plus 2I2. Take the 10 to right side. If you take the 10 to right side means it will become minus 10. Okay, na? And similarly, can you write the KVL equation for the second loop? Ma? Start from this 2. So plus 2 minus means minus or plus?
Minus 2i2
Good. Minus 2i2.
minus
Yeah, good. Again, plus 2 minus, right?
20 volts
Minus 20. Good. Minus 20.
Min-
Again, minus 2. What is the current? I2 minus I1, right? Equals to 0, right? Again, simplify. Can you simplify? Plus 2 I1 you get, right? 2 I1, right? Yes or no? Minus
4i2
4I2, good. 4I2. And take the 20 to right side, it will becomes what? Equals to plus 20, good. Simply we got two equations. Okay, now with the two unknowns, use your calculators and tell me the answers. What is the answer for I1? I will ask any students. Use your Calc app or calculator and tell me the values for I1 on it. What is the value of I1? So I1 equals to how much? And I2 equals to how much? Yeah. Okay, I'm audible, right, ma'am?
Yes.
Yeah, good, ma'am. I think I have disconnected.